Hi, I'm recording this as notes. So, solution architecture. When we go for a solution architecture, then we have to look at goals, influences, and constraints, and then current environment or existing footprints in your data center, then project management tools, and the methodology, what works best. For example, a design implementation for requirement design implementations, you might have to use kind of a methodology like agile or waterfall. So goals may vary. There can be like you intend to reduce the footprints of your existing environment, then adding agility to an environment and applications, and then increased resiliency that can be like high availability, disaster recovery, failover, load balancing stuff. Then migrating websites and applications to the cloud or other data centers, migrating infrastructure completely or partially to other infrastructures, building DevOps environments, etc. Influences and constraints. What influences the solution? So there can be budget limitations, personal skill sets, there can be like you can have some compliance requirements, compatibility, integration, reaching completion dates, current environments. Like this, another factor is current environment, where you have to see what existing footprints are there in your data center. Like where is it located, and what all conditions that you have, what all infrastructure that you have, then licensing and service level agreements and connectivity. For project management, what tools are you going to use? MS Project or Jira or something that you might use. Then again, methodology which suits you the best for design, implementation, and maintenance. So that all need to be considered when you look at solution architecture. So in architectural patterns, there are two kinds of architectural patterns that we have: isolated and distributed. So within isolated, you will find monolithic applications or traditional data center. So within monolithic applications, you will find apps that run on single server or platform, difficult to, like there would be some applications, they have legacy with respect to software or hardware. Then difficult to scale because of the legacy that they have, then tend to be a wasteful resource because of the resources it has right now. It lacks resiliency. It can be single point of contact for identification and troubleshooting. Like there can be a lot of issues within a monolithic application. Some application, for example, some mainframe based application or some Sybase kind of old database, for example, where it is difficult to scale, and then you have a lot of issues around it. That is one kind of isolated pattern that you have. And another one is traditional data centers, where you are using the same hardware, old, you need to change it, for example, or it's like it's not working anymore. It's like then infrastructure requirements are more, for example, and then this hardware requirement can be leveraged when you go for next implementation in plan your architecture. More infrastructural requirements, insufficient to manage and update, greater oversight, control of environment. So you can see insufficient to manage and update, greater oversight and control of environment. Like you can see there would be a lot of legacy here also, but you just want to take advantage of that. That all can be as a constraint, or positive or negative, both are there if you see that. Then distributed applications, what all are like applications that you will see highly available, scalable, and components can be like these components are proposed, built, and independently scaled. So you might see some images, some containerization where almost everything is independent and a plug and play kind of stuff. So as we discussed already, it can be managed and updated independently. Then resiliency, that can be tailored to meet specific requirements. Solution diagrams and documentation become more important because this distributed environment is all totally about how you have architected it. So it is important that everything is completely documented and well crafted. Resiliency can be tailored to meet specific requirements. Then cloud native data centers. So hardware, cloud native will have lesser hardware requirement because you don't really care about what hardware you are choosing, because you always go for IaaS, infrastructure as a service, platform as a service, software as a service. So those models don't really see hardware inside. You will use pay as you go model most of the time, and greater flexibility in the solution design. It's like already pioneered by whoever has whoever owns this data center. So greater opportunity for environment resiliency and more built-in services. They make interactive services, or you might get interested into some services they have crafted for common population, and that is provided by them and managed by them as a cloud provider. Some security concerns are uploaded. Like with respect to cloud, you will see most of your services are going on cloud, where it is already hardened platform, and it is expected that you will not be messing with many things with respect to security. Only thing is, whatever you leave open for the public, whatever services that you are accessing from the cloud, or whatever controls that you have on top of cloud platforms, that can be a concern. So basically, defense in depth and shared security model that you will see in cloud platforms. Security design must be addressing all the layers. So the layers would be like data, application, compute, network, perimeter, identity, and then physical security. All these layers are significant. If you are an IT professional, you know that encryption and customized application, customized compute, and well-architected network, secure network, perimeter, and then identity, granular access, and controls and policies, and then physical security. All of that are important. Security design should address them all. And then shared security would be something that you would see in a normal model. So both customer and cloud providers address this kind of securities. So a cloud provider is basically will take care of physical security. You see, will take care of infrastructure as a service, platform as a service, and SaaS. So physical security is totally completely closed. So where it is not with the customer, where whatever is there with the cloud provider, it is taken care of. Host infrastructure, then infrastructure as a service, partially they take care of whatever hosting is there. And then PaaS and SaaS, because you won't see any any host infrastructure, so or operating system level, then it is taken care of. Then network controls, partial network controls are with you, partial are with the cloud provider when it comes to infrastructure as a service. Then PaaS and SaaS completely goes to network controls goes to cloud provider. Then there are application level controls, identity and access management, and then client endpoint protection, data classification, all those controls goes to cloud provider. So then vertical scaling. If you see, scalability or high availability is important. Vertical scaling is scaling up your resources by adding CPU, memory, storage. Whereas horizontal scaling is a methodology where you create from one instance to multiple instances according to the ODMs, number of users. So this is a methodology where a same replica will of a container or a VM will be created as and when the number of users increases. So adding more servers VM to address the increased load. That is horizontal or scaling out. So reliability, availability is within the data center, and it is like multiple application layers, or you can say replica, where you have everything is redundant. Availability is mainly redundancy, where RTO is concerned, recovery time objective, as in when any machine goes down, how much time it takes other machine to take the failover or load, because it can be in a load balance or a failover mode redundancy. So load balancer, for example, it sends its signals to both, and then database is also highly available. Whereas recoverability is more of a disaster recovery, where RPO is concerned. If something goes down in the main data center, how much data loss is expected as per the SLAs? That is recoverability. And then there would be a route, and then there would be like various services that requires DNS services, for example, then change of the DNS services, and then the data that is being transmitted, that all is taken care. So that is recoverable. Then operational efficiency and cost efficiency. Well, by default, what we can say, whatever operations are there, they can be totally automated. Administrative, resource deployment, or troubleshooting. All those time that is being done when you are using administrative, resource deployment, and troubleshooting can be mitigated by automation or the policies or procedural documentation. Whereas cost efficiency is like you are going to use some architecture that is hybrid between your infrastructure and the cloud infrastructure, and it is paying you the best. So resource utilization optimization, and then licensing optimization, that comes under cost efficiency. So assessing requirements will be like clear objective, clear needs, and evaluate and justify what exactly you need and why you need it and where you need it. So then comes what is the process, current state, constraints, and then goals. And everywhere you have to see security, scalability, reliability, and efficiency. So you have assessing requirements. There would be technical, and then there would be non-technical, and then justifying your technical design and architecture. Ensure you deploy the best Azure services or any other service for Azure. Select right project and family. Though all those things are assessing technical requirements. Non-technical requirements you need to meet your business people and processes. So security, support, retention, training, compliance, all that comes under non-technical requirements. So basically, there can be a requirement, for example, where you have in-house app that you need to run on Azure. You can use Azure App Service, whereas this technical requirement is met. But non-technical requirement-wise, you have your own support staff. Then you can use standard support from Azure and continue to use your own workforce. So that technical requirement has been is also met. So let's go to next. So assessing non-technical requirements, common items, reduce the overhead, then improve resource tracking, non-technical, that all stuff is there. So other non-technical requirements. Thank you.